Hey, hello everyone and welcome in a new video. Today we will discover a new practical exercise, and in the first part of this video I explain you how to handle this exercise with the design pattern, the design architecture that we want to use. We will reuse the Dockercoin application with the same components, and to introduce and to use config map and service, we will just redesign this application and try to use custom ports or to use custom configuration and settings. So let's go. Don't forget to subscribe to the channel to not miss the next video. Like and comment this one to support me, of course, and let's go. So the first thing that I can say, thank you at Jerome Petazzoni to allow me to reuse the Dockercoin application, and I just adapt the code about each component to try to set up some element like port, like sleep duration, to make a little pause for some components, and to change the design about some little things. So let's go. What is the change? Remember, you can find each component, the web UI, of course, and the web UI can just query the Redis instance, and we have the RNG component. This RNG is the random number generator, and of course it's a Flask application, and we have a worker. The worker query first the RNG. The RNG give to the worker just a random number. With this random number, the worker just query now the hasher, and the hasher generate a hash about this number, and the worker after that in the third step just store this number inside the Redis, and of course the web UI just can give us some statistics about this generation number. But to change that and to try to use a config map as beginners, I suggest you to just change the little things inside the architecture. So of course we keep all components, but for each component we try to change first the port and the internal DNS inside our Kubernetes cluster. For example, for RNG, we have basically the port 8081, but we want that the worker can use the RNG with a query by a DNS xRNG on the port 80. And to do that, of course, the solution is based on the service, so you can set a service to set a service based on xRNG entry and the port 80, and remap it to our pod RNG 8081. And we can do the same thing with hasher, and you can, for example, set a new entry, DNS entry, with a service xhasher and the port 8082, and we keep the port 8082, for example, here. And you can of course set the port inside the config map, just to set each component. For example, in RNG, you can set the port, the sleep duration, as environment variable, or as just a file that you can pass to the application. We will see just the first example, and in the second part of this video I will just give you the answer about this exercise. So we do the same thing with Redis, so to create a dedicated service for Redis, a dedicated service for Redis used by the worker and used by the web UI, like that. And you can see that we have some dedicated ports that we can set inside for the worker in the worker configuration, and the same for the web UI. So make just a little pause, try to translate each element, so the mapping, so each DNS like that, the port that we want to use, like here and here, and also sleep duration, but you can change the sleep duration as you prefer. So let's go the first example with RNG, and we want of course to use XRNG. I can just show you the example. Let's go on our cluster. I can mcd here Dockercoin like that, and now we are ready to create our application. So you can find the video description so the repository, and in each repository you can find each video directory. We are in 27, like you see. I can go inside inside the Dockercoin, Xavkeycoin, because this is just similar as a Dockercoin, but for Xavkey, because I just adapt the code for each component. Okay, and now what we want to do, we want to begin with RNG. So for RNG, you can see that we have a config map, we have a service, and of course we have the deployment about the RNG. The first thing that we can check is the config map. What we can do in the config map, we can set the port, like here, to say that we want to listen for RNG, and on the deployment, on the pod, we want to listen on 8081. This is not the basic port, because the basic port is 80, if I remember well. And the sleep duration, just to test, is 0.2 seconds. So we can push it, kubectl apply -f and cm RNG. Oh, no, I'm not at the good place. What we can, oh yes, we can just go inside the Dockercoin here, and we can copy this Xavkeycoin directory, just to be quick. We have the Xavkeycoin directory with all manifest inside it, and we can copy it inside our K0s directory. So we are K0s stack here, and we can copy it just temporarily, of course, inside it, and that means that inside the vagrant directory, because we are in the same directory, we have the Xavkeycoin just here. So I can copy all elements that we have inside the Xavkeycoin directory, inside vagrant, Xavkeycoin star, and we can copy it here. Okay, so let's go. kubectl apply -f cm RNG, we say that, okay, and kubectl get cm. Now we have our first config map, and of course we can check kubectl get config map RNG and -o YAML like that, and you can see that we have a file named config.yml with a block with the port and the sleep duration. This is exactly like we want to do to create the file config.yml. After that, we need to create the deployment too. So to do that, we can just have a look on the deployment of RNG and what we do inside it. Of course, we want to use the config map. Yes, the config map and the specific the dedicated key for config.yml. So the key is config.yml, but we want to mount it inside the pod with the same name, config.yml. Okay, we use the config map name RNG, and we just give a name to this volume with RNG-config. Okay, So now we want to create basically a deployment with only one replica. We match label on app RNG, okay. And you can just copy the same thing that we used in the previous practical exercise with Dockercoin. And inside the container, you can see that now we use Priximo /RNG and dedicated tags. This is my Docker Hub username, Priximo, so you can reuse this file with this image without don't take care about the source. Okay, and after that, we want to mount inside our container our config, and by default, this image and the code take the file config.yml if this file is in /config.yml. So let's go. We can apply the file. You can see here -rng like that, and now we can check kubectl get pod, and just take a few seconds to download the image. And after that, we have a container up and a pod up and running. If I check the logs of RNG, and seems to be good. We listen on the port 8081, so it's good for us. Okay, and now we can use a service just to remap, because by default we already saw that we use RNG service with kubectl expose, but we can't use kubectl expose because the name of the service is not exactly the same name as our deployment. So to remap it, we need to create by the end the xrng things for our service. And to do that, we can just use svc xrng like that. We create a dedicated service xrng and to generate the DNS entry inside our Kubernetes cluster. And what we want to do, we want to use the target port. So this is the port of the pod, and this is the port 8081, and we want to map it with the xrng entry and the port 80 about our service. Remember that a service is just a load balancer with a DNS entry, and that allows us to remap things if we want. Okay, and of course we need to select some pods that we want to serve through this service. And to do that, we need to have a selector based on label and app equal RNG in this case. And we don't need to use this service outside of our cluster, and we don't want to have a port exposed on our servers. And to do that, we just need to be secure and use the type of this service and set it to cluster IP. So let's go, kubectl apply -f svc rg like that, and kubectl get svc. We have the service, and how to ensure that the service map some ports. What we can do, we can use kubectl get endpoint or EP, and we can see that we have our service and it map a dedicated pod. So take a break and try to do the same thing. Take care about to use the port 8082 here, and with a service based on xhasher. You can reuse exactly the same parameters. On the worker, you can, and on the Redis, you can set the service also. And of course, on the worker, you need to set, for example, environment variable like that, to set each service, the Redis port, the Redis host, the RNG port, the port 80, and the RNG host. The host is of course the entry of our service, so xrng, and same thing for Hasher. You have the port here and you have the host here. And you have the same thing for web UI, to just connect your web UI directly to your Redis. So you can use either the Redis environment variable, or you can use directly the config file, the config.yml file. So take a break, let's go, and now I switch to the second part of this video. Sorry. So let's go. Let's go for the answer, and now what we can do, we can run the hasher, and the hasher is on the port, so we have a config map, of course, for hasher, and what we set the port and the duration. This is exactly the same thing that we had inside our previous config map. I don't see, yes, but in the previous config map we set a config.yml, and we can switch and to use environment variable. This is just a choice, but you can use either the config map or either the config file with the config map. Okay, so I can apply the hasher config map for hasher like that, not H but F. Okay, and now we can apply -f the deployment, so we can have a look on the deployment about hasher, and what we do inside it, we just mount, because this is some environment variable, only 2 environment variable, and we don't take care about the number and if we have some other environment variable. So we just want to mount inside our pod, and you can see this is just 3 lines to just say we want to mount all keys that we have inside the config map named hasher inside our container. So let's go, kubectl apply -f and the deployment about hasher. Okay, so now that takes a few seconds just to start the service, the component, and of course now we need to set the service, and of course svc hasher, and what we have inside it, the target port is port 8082, and we want to keep it, so we can set it to 8082, but we want to use a custom entry, DNS entry. So to do that we need to have a good name for our service, and the right name for our service of course is x hasher cluster IP2, because we don't need to access it from outside. And let's go, kubectl apply -f svc hasher like that, or like that. And if I check again, so we have the hasher up and running, and if I check the endpoint about xhasher, it's okay. So for the other thing that we can do, we can just run our Redis. Okay, so for our Redis, what we have only the service, because we just need to remap only here the name to join our Redis, and we don't change the port or stuff like that. So first thing that we can do is to run Redis. So with kubectl apply the Redis like that. Okay, so we can have a look on it, of course. Nothing's changed if we compare that to the previous practical exercise. And we can apply, of course, we have svc redis just to remap the x redis, and we keep the same port, so it's really easy. And of course cluster IP2, kubectl apply -f and svc about our redis. Now we can do the same thing with worker. Worker hasn't a service, because we don't need to join the worker. The worker just pulls some information about each component and push it inside the Redis, so we don't take care about how to join the worker, but we need to set how to join each component. So xrng port 80, xhasher port 8082 and the Redis with the same port. So how we can do that? So we can check that we have maybe a config map about our worker, and yes, we have a little bit more key inside our config map. We have only one key, sorry, the config.yml, but we want to set inside this config file the Redis host, and we set xredis and its port, and the hasher host here, xhasher, the port to x host, RNG host here, and maybe RNG, and we keep the port 80. Yes, we keep the port 80. It's really interesting because we change the default port on xRNG, but to keep the default port that the worker used, we used the service based on the same port that the worker can use directly. So we just need to change the RNG host and not the port. And we can add the sleep duration. Okay, kubectl apply dash fcm worker. Okay, and now we can also deploy the worker. The worker is here, and we need to mount again the config map worker, and we want to use a specific key, config.yml, and the path is config.yml, and we want to mount it inside our container, the worker container, and now it's okay. So I kubectl apply dash f d worker, or okay, and kubectl get pod. Now I think we will have a worker up and running. Okay, perfect. And the last component, so the web UI, and we need to set it. So we can check the config map about the web UI, and if we check it, what we have the Redis host. So because we change the default host, xredis, the Redis port, it's a default port, and the listen port on the port 8080. Okay, kubectl apply again, and we can use the cm web UI. Okay, and now we can also check the deployment of the web UI like that, and we do the same thing. We mount the config.yml inside the web UI container. Kubectl apply dash f d web UI, and finally we need to use also the web UI service like that, and we want to have a target port, and also because we need to access to the web UI on a node port, we set a node port, you can see here, and we can apply that with the same and basical command. And now I think we can just use kubectl get ep to be sure that we have all service inside it. Okay, and yes, we have all service up and running. And now kubectl get svc, we have the node port, so we can use it just to check that it works. So I can just go on a new page, a new tab, and we want to go on the server, on this server, and we need to use the external IP like that, and the port, yes, this port is 31 and 111 like that. And now, yes, we have our Dockercoin, and this is just the beginning, of course, and you can see here that we have some new coin inside it, and you can if you want to play, you can change the sleep duration on some component to check if we can increase some little stuff. For example, you can just kubectl scale the deployment worker, and I want to have more replica on it, and maybe 10 replica. So kubectl get pod. We have 10 worker, and maybe that can be better. Yes, cool. And maybe you can just change the sleep duration. And remember, really important thing, that if you want to change the config map, for example, on worker, because here we just wait 1 second to make another task. For example, if you want to pass it to 0.1 for 100 milliseconds, you can edit the config map about worker and just put here 0.1 like that. We can remove the, or just set the replica to 1, just to go back and roll back our change. And we want to increase and reduce the sleep duration to improve our performance, or simulate that we want to improve our performance. And to do that, kubectl apply -f the config map about our worker, so it's okay. Configure, that means that we change something, because if I push it again, unchanged, that means that we don't change anything into it. But no change normally here. Normally we can have more coins per second, but no change, because if I check, no, the worker pod is not restarted and don't take care about the new configuration. So if I check inside the worker node, kubectl exec-ti, and the worker node pod, sorry, and if I go with a bash into it, no bash, just sh, yes, like that. And if I just use env, if I check the duration inside it, if I can find it, of course, where is the duration? I can use a grep, dash I on duration. Nothing on duration. Maybe why? Okay. What I have inside the config map? Yeah, this one. This is the config.yml. Sorry. Okay, I can try, but no. Here, and if I just cat config.yml, you can see that we keep only the sleep duration. So to change that, we need to restart the pod and kill the pod to do that, or kubectl rollout. We already saw this this command line. What we want to roll out, we want to roll out or to restart the deployment named worker, like that. Sorry. Yes, rollout restart. And with that, we just terminating and create a new pod with, I think and I hope, with the new configuration. To check that, kubectl exec-ti and the pod here. This is the new pod, --sh and cat and the config file. And it's okay now, and I hope, yes, we increase, not a lot, because maybe the bottleneck is not the worker node. So we can see maybe we increase, yes, we increase not at the same time the coin number, but you can see here maybe we just have more spike, but it's not a lot. And maybe this is due because our hasher has some limitation, because we have some on the hasher we have some sleep duration. So you can see that the sleep duration is 3, and that means that the hasher take 3 seconds just to sleep, to pause, and no give information. So we can change it too. So we can edit the config map about hasher and put it to 0.3, for example, and kubectl apply -f, and we can use cm hasher and kubectl rollout restart again about the deployment of hasher, like that, and kubectl get pod. We have a new hasher here, okay, and so we can check if yes, we improve a little bit our miner, so it's better. Cool. So you can play with that, and you can edit the code if you want also. That's it for today. Thank you for following this video. Don't hesitate to subscribe to the channel and visit the homepage of the channel, because we have a lot of videos about Kubernetes, and see you in the next video. Bye bye.